This presentation outlines some of the post-harvest handling practices that can be used by small-scale or low-input growers, packers, shippers, and marketers of fruit, vegetable, and ornamental crops. There are two main objectives of applying post-harvest technology. First, to maintain quality, including appearance, texture, flavor, nutritive value, and food safety. And second, to reduce losses between harvest and consumption. Post-harvest handling systems involve many interacting steps. Produce is generally handled by many people before final sale to consumers. A general series of handling steps will be followed in this presentation. Each practice will be briefly described. For further information, refer to the publication titled Small-Scale Post-Harvest Handling Practices, a Manual for Horticultural Crops. Application of these practices can help small-scale handlers maintain the quality of fruits and vegetables and ornamentals while reducing handling and marketing losses. Fresh produce and ornamentals must be carefully harvested at their correct maturity stages. Use clean, smooth harvest containers. Provide shade for filled field containers and cool products as soon after harvest as possible. Harvesting practices should cause as little mechanical damage as possible. Digging gently, using sharp knives and clippers, and picking and handling carefully will lessen damage. Pickers should wear cotton gloves or remove rings and trim fingernails to avoid damaging the commodities they handle. For some crops, a natural break point forms at the junction of the stem and the stalk. Plastic containers are relatively expensive, but are durable, reusable, and easy to clean. The containers can be lined with a sheet of foam to help reduce injury to delicate commodities such as asparagus and soft fruits during transport to the packing house. Field packing reduces the amount of handling of a crop between harvest and consumption. When head lettuce is field packed, some wrapper leaves are left on the head to help cushion it during subsequent handling. A small cart helps reduce the bending and lifting by a picker during harvest. This mobile unit for field packing is designed for use along the edge of a field being harvested. It can be used for packing many types of commodities. The roof provides shade during packing, but folds down for easy transport. Shade should also be provided for the packed boxes of product. Root crops like sweet potatoes, cassava, or yams should be cured if they are to be stored for any length of time before marketing. Curing requires high temperature and high relative humidity conditions for a short time. Curing heals harvesting wounds by providing a new protective layer of cells. Yams and other tropical crops can be cured outdoors by piling them in a partially shaded area. Straw can be used as an insulating material. The pile should be covered with canvas or burlap and left for about 4 days. Under controlled temperature and humidity conditions, curing is faster and more uniform. When curing with heated air inside a storage facility, a bottom to top forced airflow results in the most uniform distribution of heat. Wetting the floor helps to increase the relative humidity in a curing chamber, but if it exceeds 95%, it may increase the spread of decay. The curing of onions, garlic, and flower bulbs refers to the practice of allowing the external layers of skin and neck tissue to dry out prior to handling and storage. These crops can be cured outdoors in windrows or in sacks, stacked in rows. The cut foliage of the plants can be used to provide shade during the curing process. Onions, garlic, and flower bulbs are also cured in temperature and humidity-controlled chambers. Curing with forced heated air is sometimes used in regions where ambient relative humidity is too high for successful natural drying. If the heaters are located near the ceiling, fans are then used to help move the heat downward into the produce. Bulk bins must be stacked with a gap of 10 to 15 centimeters or 4 to 6 inches between rows for adequate air circulation. Packing house operations typically include dumping, cleaning, waxing, sorting, sizing, and packaging. All packing house operations should be covered to limit product warming, protect produce from rain or hail, and provide more comfortable working conditions for workers. Shade can be provided by using a simple canvas or plastic mesh sheet hung from temporary poles. Or operations can be located inside a permanent roof structure. During packing, careful sorting is required to remove decayed, injured, immature, or over-mature produce. Eliminating decayed produce will limit the spread of disease. Removing injured, immature, or over-mature produce saves energy, since culls will not be cooled or handled further. Commodities may need to be cleaned by washing or dry brushing. Washing may be desirable for some crops, especially root crops. Here, ginger is being immersed in a water bath. Then sprayed to remove any soil and debris. Sanitation is essential during washing. Using a wash solution containing 100 parts per million of chlorine will help to control the buildup of pathogens during packing operations. Hypochlorite powder or liquid is inexpensive and widely available. Installing a demand system is useful for maintaining the proper chlorine level in packing house wash water. Small-scale packers should test the level of chlorine several times daily using a simple test kit. Produce should be sorted into quality grades before packing. Sorting may be by maturity, size, or color. Horticultural products are generally packed for ease of handling. Waxed cartons, wooden crates, or plastic containers are preferable to sacks or open baskets. While these containers are initially more expensive, they can stand up to the high relative humidity found in storage rooms and protect produce from damage when stacked. Rigid plastic containers are easily cleaned. They can be reused many times. For best handling results, containers should be properly filled, neither too loose nor too tight. If containers are only partially filled, vibrating produce causes abrasions or bruising to the neighboring units during transport. If containers are packed too full, compression damage results when containers are closed and stacked. One recommended method for reducing damage is to fill the container spaces with shredded newspaper. It's an inexpensive and lightweight filler. A wooden lug is a typical container for table grapes. This container is very sturdy and maintains its stacking strength during long periods of time at high humidity storage. Often, a paper liner is folded over the grapes before the top of the lug is nailed in place to protect them from dust and water condensation. Fiberboard boxes can be manufactured in many sizes and shapes. Containers must be vented with approximately 5% of the surface area of each side open for proper air circulation to occur. If used for forced air cooling, the side vents must align when containers are stacked squarely on top of one another, corner to corner. Adding a fiberboard divider to a carton increases stacking strength. The use of dividers is common with heavy products, like melons. When locally made containers have sharp edges or rough inner surfaces, a simple, inexpensive liner made from fiberboard protects the produce from damage during handling. Handling packages as unit loads can reduce the work associated with post-harvest handling. Here, stripes and corner boards have been added to help stabilize the load. Modified atmosphere packaging is used with strawberries and bushberries. A single pallet load of berries is sealed within a shroud of 5mm polyethylene sheeting on a pallet base covered with a plastic sheet. Enough carbon dioxide is injected via a small hose into the bag to create the 15% level, which is effective for decay control.